Hello everyone and welcome back to our course. In the previous lecture we learned how to build references, and let's just move that into another function because coming up in this lecture we're going to learn how to build classes and objects, which are the fundamentals of object-oriented programming. So let's just move all of these lines, cut them, and put them into their own function so we can have them for later. Call this our build references function, and we'll just paste in all that code. Next, let's create our first class. Typically, to create a class, you create a new file in your solution. But we can start off just by building it here in our C++ file, and then we can move it. To create a class, you use the keyword class followed by the name of your class, such as player. Then you open curly brackets to open up the class body. A class is a way to represent an entity like a player. And the point is that you can reuse a class to make multiple instances of a player. And these are known as objects. So we use a class to make multiple objects. You could have a class for player, for food, for weapons, and more. Anything that you need to represent as an entity. A class will have properties and functions that are specific to that class. For example, a player might have a health property, XP, a name. Anything that describes the class is a property, and that is a variable. As well, a class can have class-specific functions. For example, a player might be able to run and attack, whereas another class, like a tree, might be able to just grow and shrink. So you have different classes in order to separate different properties and functions. For example, what if we wanted to give some properties to our player? First, we specify the visibility of these properties. For example, public means that these properties can be accessed directly outside of the class. They can be accessed anywhere. So we could create here something like an int health. As well, we could do an int level, an int XP. We could also do a string for the name and more. These are all properties of the player. So how do we actually create an instance of a player? Well, we can do that somewhere outside of the class, for example, perhaps in the main function. To create a new instance or object from a class, it's similar to making a variable in that first you pass the data type. And this time the data type is player. That's right, each class can be used as a data type. So you can create your own data types, and these are known as reference types instead of primitives. An int or a char or a bool, those are primitives. They're part of the C++ language. But a class like player, C++ didn't create that. We created it. So that's why it's known as a reference or an object data type. After that, we pass in the name for our variable, such as player 0. So here we've specified the type and then the name. This can be any name we want. Then we use an equal sign, and this time we have to give a value to the variable, and it has to match the data type player. So what we do is we call player with 2 parentheses at the end. This is like calling a function, but what we're doing here is we're calling the class constructor, which already exists whenever you create a class. And what this does is it creates a new instance of a player, and it stores that in player 0. Because this is a reference type, player 0 is actually storing a memory address to where that object exists in your computer's memory. Now we can change any of the public properties of the player directly. For example, the name. We could take player 0 and set its name property directly. And typically, with properties that are public, you will have them actually be uppercased. So let me just change all this. Okay. Now I'm going to change the name here. Notice I have to change the capitalization because C++ is case sensitive. And let's assign this player's name property. Note that it has to be a string because that's the data type of name. We could call this something like our archer. Alright, now we have just directly changed a property of the player 0 variable. So we could print out our results of player0.name to show that we actually indeed were able to make the change. And when I press debug, look at that, I get archer being printed out in the console. And I can change the properties of all of the properties that I set that were public. You can directly access those. With player0.health, you could change that to 2. Player0.level, you could change that to 4. Player0.xp, you could change that to 200. So here we go, we can directly access the properties of that object. I could also create another player object called player1 and instantiate a player again. And this time these 2 players are going to be completely separate. So they act independently. They're 2 different variables. They just have the same data type. If our class had a private variable or even a protected variable that was a property, then it couldn't be accessed outside of the class. For example, let's say we had a private here and we had a string called username or password. These are known as private properties, and they're only accessible inside of the class. And we'll look at them more later on. Now, typically when you create a class, you don't want to throw it all into just the same file as main, because often you'll have a lot of classes as part of your game or your project. So instead, you'll make each class into its own file. So let's do just that. We can remove this class player, or we could keep it if we'd like. Doesn't really matter. We can keep it for reference. Then let's go to our Solution Explorer. Click on your project, which is just underneath the solution. And then here we're going to right click, and then we're going to go into Add. So let me just go up a bit here. We're going to go into Add and select Class. This will allow us to add a new class to our project. Here we're going to specify the class name, so we could call this player. All right, then immediately C++ or Visual Studio, it's going to create for us player.h and player.cpp. So whenever you create a new class as its own file, you will have for you the header file and the C++ file. The header file is where you declare your properties and functions, and the C++ file is where you actually implement them or initialize them. So these two always work together. Press OK, and let's see, we just have to register the class. Let's see, looks like we already have a class called player, that's why it doesn't want us to do that. So let's just remove that for now. We can just add it back in later. Then let's right click, let's go to add class, and let's try player again and press OK. There we go. Now we can create it because it doesn't already exist. You can only use a class name one time. So now you'll notice in our header files folder we have player.h that has been created, and in our source files folder we have player.cpp that has been created. They are mostly empty. Player.h just has here the class template. Player.c++ just has an include line to player.h, which is required because these two work together, and this line is saying that we want to be able to access any properties or functions that were created in the header file. Now, let's go ahead and create our player class inside of our player.cpp and player.h. We're going to begin inside of player.h. Here we are going to make a public category, and first we're going to make a call to our constructor. So here we're declaring the constructor player, and we'll have to implement it in the C++ file as well. Next, we want to bring back in all of the properties that we just made. So we had our int of XP, we had our int of health, we had our int of level, and we also had our string of name. All right, and to be able to use string at the top of the class, we do have to include string here. All right, great. So now we are able to bring back all of those in. Now, let's also go ahead and fill in the C++ file, which you have to do. You have to give, for example, your constructor definition, as well as implement any functions part of the class here in the C++ file. Because the header file, that is just for declaring. The C++ file is for implementing. Let's start with the constructor. Remember, the constructor is what we use to create each instance or construct an object from the class. And to create a constructor, first you specify where it comes from. It comes from the player class. And then you call the name of the constructor, which is always just going to be the same name as the class. And it looks like a function. A constructor is just a special type of function that has the same name as the class. Then here in the constructor, you could set different values of your properties. For example, here we get messages that health, level, and XP are uninitialized, and we should always initialize a member variable. These are warnings in yellow triangles, which means they're not required to be changed, but they're highly recommended to be changed. So let's apply their advice and let's give a value to all of our properties. We have XP. We can give our player a starting XP of 0. We can give our player a starting health of 100. And we can give our player a starting name of nobody. Alright, so here we go. Now our warnings disappear because we've given our 3 properties values, and we have to do that inside of the constructor. Alright, so there we go. In our C++ file, we've implemented the properties. In our header file, we just declare them. So these two are always working together, and you'll see that more later on. So now, inside of our main file here, let's just hit debug to compile all of our code. Let's see what error messages we get. Okay, we have to make sure that our player is defined. So in order to be able to use an external class inside of another file, for example, to use the player class in Introduction to C++, inside of that file, to be able to use one file inside of another, you have to use an include statement at the top here of your Introduction to C++ file. So we're going to include our player.h. We don't have to include the player.c++ because the player.h contains all of the definitions for the properties and functions inside of player.c++. So now if you scroll down, you'll be able to see you're able to use the player class as a data type. And you can hit run and you'll be able to see the archer again, just like before. So this time we're again just creating players, but now we have our class in a separate file because you don't want to dump all of your classes into one file. You want to separate each class into its own header and C++ files. You'll notice here inside of our C++ file, we were able to take the default name of player 0, which was nobody, and we were able to change it to archer. And same with all the other values, as long as they're public. Coming up next, we're going to learn how we can get and set private variables, as well as learning how we can actually set these properties of an object as soon as it's created, instead of having to do it manually after it's already been created. So join me coming up in our next lecture. We're going to continue learning a fundamental topic of object-oriented programming, classes and objects. Hello everyone and welcome back to our course. In the previous lecture, we learned how to build a class and build objects from that class. In this lecture, we're going to continue our look at classes and objects, and we're going to learn how we can get and set private properties of a class, because you'll see this often come up. Here we can see inside of our player header file, we have 4 different properties, and currently they're all public, which means they can be accessed outside of this class. You can just directly take the player and change their health or their level. But often you'll see not only will you have public properties, but you'll also have private properties. You'll see this frequently, and protected. So you'll have for example, a private category and a protected category as well. Private means that the variables can only be accessed inside of this class and nowhere else. Because sometimes you want to keep your data private in one class so that your code is cleaner and people can't just change one of your properties without you being able to set the conditions. For example, what if somewhere in the code you accidentally or someone else tries to set health to be less than 0? You might not want that to be allowed. So by making your health private, you can put conditions onto what the value of health can be set to. Otherwise, anyone could just set your health to anything, and this can be quite dangerous depending on the project you're building. It could break your project or it could break your whole company. All right, so that is why often private properties are created, as well as protected. The protected category means that properties inside of that category can only be accessed by this class and any children of this class. So there is the concept of inheritance in object-oriented programming, which means I could make a class called my archer player, which could be a child of the player. And what this means is that it could have all of the same properties and functions of its parent, and then even more specifically to an archer. And then you could have a warrior player, which is still using the properties and functions of the player class, but then also has its own warrior specific properties and functions. So let's start by looking at private. We're going to see public, private, and protected a lot throughout developing with C++. So what if we wanted to have a private variable, such as, for example, a string that said what type of weapon the player had? So we can call this player weapon. Here, this, because it's under the private category, it's a private property of the player. So if I try to go into another file and I try to access a player's property of this weapon, I actually won't be able to. We can set player weapon inside of our C++ file. We could set this by default to no weapon, because this here, this C++ file, that contains the constructor, which is still part of the player class. But anywhere else, we can't actually access player weapon. For example, let's say I tried to take player 1 and change its player weapon type to something like a sword instead of no weapon. You're actually going to get an error that says that the property is inaccessible because it's private. So how do we get around this? What do we do? The answer is that we can make functions known as getters and setters to get and set the value of a private or protected or even public variables. Let's start with using a getter. So we're going to begin inside of our header file, where we have to declare any functions, and these functions are going to be public. So I'm going to create here the string data type for the function, and I'll call it get player weapon. Here I'm just declaring the function, then I have to actually implement it inside of the C++ file. Notice here that get player weapon, it's public, so I can be able to access it outside of this class. So now we can go into our C++ file, and here let's go ahead and actually initialize that function. It has to be outside of the constructor because it's its own function. The data type was a string. Then the class it came from is player, and its name is getPlayerWeapon. Notice here, whenever you reference a function inside of a C++ file, you have to first put the name of the class where it comes from, followed by these 2 colons, kind of like how we did with standard string, because that is where this function exists. Then we can fill out the function body, and here we're going to return this, and then we're going to access player weapon. This refers to this instance of a player. So this class. Whenever you see this, it just means this class that you're in. And we're getting its player weapon. Notice here you have a dash and this greater than sign, creating this arrow-like symbol. It's just a dash or a hyphen followed by that greater than symbol. What this means is we're pointing from the class. We're just getting its player weapon. We could do this with other properties like health as well, or name. It's just a way that we can grab a property from a class. In this case, the class is player and the property is player weapon. We can't just access player weapon on its own. You want to include pointers here, typically where we're pointing from this, we're pointing at that player weapon of this. And you'll see the syntax here coming up often with not just this, but with other classes as well, like perhaps food, a food class, or an enemy class. So you want to get used to the syntax. Alright, so now in our main function, we can actually access and get our variable value. All we have to do is grab our player and get its player weapon. We're just calling that function getPlayerWeapon. And we could even print that out, and we'll see that we have our default value for a player weapon. So that's how we can actually access a private variable, by using a public function as the intermediary. So that's why we have no weapon being printed out. But what if we wanted to actually give our player a weapon? We can't directly touch that private variable, but we can create what's known as a setter. This is going to be another function part of the player class, and again, it's going to be public. Let's start in the header file, where first we'll declare the type, which is going to be void, because we're not getting a value, we're setting a value. And we'll call this setPlayerWeapon. Inside of setPlayerWeapon, we're going to pass in here a string that is going to be the player weapon parameter. So whenever we call setPlayerWeapon, we'll have to pass in some value. Then inside of our C++ file, we can initialize that function. So let's go ahead and make it void, because that's what typically set functions are void. Then it comes from the player class and it's called a set player weapon. Also, this function has to take in one parameter, which we saw it was a string and it was the player weapon. Then inside of this function we can actually directly set this player weapon. We can directly set it to the player weapon argument or parameter that's passed in. So that is how you can access a private variable, by having this intermediary function. You may be wondering, what's the point of using this function? Why would I make my weapon private in the first place if I can just use a function to access it and change it? The reason is that with these intermediaries, you can actually set conditions. For example, let's say I didn't want someone to put in the wrong or invalid player weapon. I could do a check. I could check to see if my player weapon, for example, is not equal to a null pointer. So I could check to make sure it's not equal to null here with this not operator. Not for the string though, but for another argument. So you can add conditions here. You could check if player weapon dot empty. You could check if someone's trying to pass in an empty string for your player weapon. Then you could prevent that from being allowed. So here I have if dot player.empty, and I could open up curly brackets. Alright, and here if I add a not operator, which is an exclamation mark, then what we're checking here is if the player's weapon is not empty, then we can use it. So this is just one example of using a condition to make sure that someone's not trying to put in an improper value, because your beta testers or even your players, whoever's using your project or game or application, they'll often do things that you don't expect and try to put in values that are invalid, whether by accident or on purpose. So by protecting or making private some of our properties, we can make sure that we don't get invalid values, such as here. We don't get an empty player weapon string. Or for example, we don't get negative numbers in our bank account, or we don't get health ever being allowed to go below 0. These are not required, you don't need these conditions, but they are to show you what's the point of having a getter and a setter, so that you can specify the conditions of what you will accept, and your player can't just set the player weapon to anything, or a hacker or a fellow person working on your project, they can't just set the player weapon to anything, because that could potentially break your project. So it's in order to protect your project. Join me coming up in our next lecture. We are going to learn how we can set properties of our objects directly when we create the actual object itself, instead of having to set them after the object has already been created. This is very commonly done and quite important to know. We're almost done with our C++ introduction, so join me in our next lecture. Hello everyone, and welcome back to our course. In this lecture, we're going to learn how we can build parametrized constructors in order to immediately set the properties of objects when we create that object. We remember that a constructor is what we use in order to create an instance of a class or an object from a class. Here we've used a non-parametrized constructor, which means it doesn't take any parameters. Because remember, a function is like a constructor. A constructor is just a special type of function. You can see we have the name, which is the class name, followed by the syntax for a function. So we can actually create multiple constructors that take in any number of arguments or parameters. Let's start in the player header file. Here we can see we previously created a definition for just the non-parameterized constructor. Next, let's create another constructor definition, but this time it's going to take in all of our public properties. So we are going to pass in our int for XP, an int for health, an int for level, and a string for name. Okay, now because we declared this constructor, it's like a function. We have to go into our C++ file, and we now have to create the body of that constructor. And it's going to be similar to the body of our non-parameterized constructor. In that, first we reference the class where it comes from, which is the player. Then we reference its name, which is the same name as the class. A constructor always has to have the same name as its class. Then we have to grab all of these parameters and pass them to that body. So let's just paste those right here into these parameters. So we're taking in an XP, a health, a level, and a name every time we create a new player. So now we can create a player either with no parameters, or we can pass in parameters. Then inside of this constructor, we can take this and take our XP and assign it to equal whatever XP was passed in via the constructor. Same with the health for this player object. We can set it to take in the argument for the health. The same with the level, and the same with the name. Okay? Be careful here about the capitalization. Okay, the lowercase variables refer to the parameters. The uppercase ones, or camel or Pascal case or title case, they refer to the actual properties of the player. This is typically what's done. You'll see here your parameters will be in lowercase and your properties will be in uppercase. That's because we have to differentiate them. If we accidentally flip these two around, then we actually wouldn't have this code even work, because we're trying to set a parameter to a property. So you have to be very careful. You could even call these, for example, something like input underscore XP if you want to be super careful about not mixing those two up. But then with time, as you code more, you'll have no problem making sure you don't mix these up. But again, you do have to be very detail oriented. So now let's go ahead and create a player with this second option of a constructor. So here I'm going to go back into my main function. I'm going to create a player that I will call player 2. This time, instead of just calling the empty constructor, I can pass in values for my XP, such as 300. And look, I even get a little prompt. For my health, I can pass in 100. For my level, I can pass in 3. And for my name, I could pass in magician. Okay, so here I have passed in 4 parameters because that is what that constructor takes in. And note, you have to pass them in the exact order that you want them to be sent to the constructor. To make this more clear, I would turn all of those magic numbers into variables or constants. For example, I can create here an int for my player 2 XP, and I can set this to 300, then an int for my player 2 health, or yeah, I think it was health, yes, a level 100, and then for my player 2 level, which is 3, and my int for player 2 name, which is magician. That way it's a bit more clear what you're trying to pass in. Oh, by the way, this wasn't an int, this was a string. Let's just change that data type. And then we can take those variables and pass them to the function. All right, so there we go. That is how we can build out another player using here our second type of constructor. And we can create as many constructors as we want, as long as they take in a different number of arguments or different data types for the arguments, or they have a different order of the data types. And we can even test this out by calling one of the properties of our player 2, such as their weapon, and then we can hit debug and we'll be able to see no weapon is being printed out. Let's see, and we have no weapon here because we didn't actually set the weapon for that. We can grab a public property, like for example their name instead. We can just directly access that property because it's public, and look at that, we see magician. So that verifies that we were able to successfully create player 2 and also set its properties as soon as we actually created it. We're almost done with our C++ introduction, then we can get into developing projects with C++. So join me coming up in our next lecture. It'll be our last C++ introduction lecture. And we're going to talk about how we can point to and reference objects. So we'll go back to pointers and references to talk about how they work with classes and objects, and also we'll mention how to build functions inside of our classes, because we haven't actually built any functions to perform actions besides here this getter and setter. So I will see you in the next lecture. Hello everyone, and welcome back to our course. In this lecture we are finishing up our C++ introduction. we're going to learn how to point to and reference objects. So first, let's start by making a pointer inside of our main function to one of our players, like player 2. Remember, to create a pointer, first we specify the data type followed by an asterisk. Then we have player 2 pointer as our variable name. And the value has to be an ampersand player 2 because we're referring to the memory address of the player 2 variable. Okay, and we can test this out. We can go ahead and log out the value of our player 2 pointer, and we'll see that it holds a memory address pointing to player 2. Okay, next let's also create a reference to our player 2. So you'll notice that creating a pointer and a reference to an object type is the same as creating a pointer or a reference to a primitive type. So for a reference, we just use the data type followed by an ampersand. Then we'll call this player 2 reference, and we'll assign it to equal player 2. Okay, and if we now paste out the value of player 2 reference, we'll see that we actually can't because player 2 is an object type. So we would have to instead get one of the properties from this, such as the weapon or the XP. For example, we could grab XP. Then if we hit run or debug, we'll see 300 will be logged or printed out because the player 2 reference is a stand-in for player 2. If we want to access variables and functions from a pointer versus from a reference, well, for a pointer we have to use an arrow, but from a reference we have to use a dot. So let's start with the pointer. Let's say we wanted to grab, for example, the variable from our player 2 pointer. In that case, I'm going to grab here my player 2 pointer and use an arrow or a hyphen followed by the greater hand symbol, and I can get one of these properties such as the level. Okay, that is how I can access the level of my player 2 pointer, which points to the memory address of player 2. Alright, so we can also test this out by printing it out in our console. So I'm just going to take this exact line and paste it in. Then I'm going to hit debug, and we're going to see 3 is going to be printed because that is the level of player 2. So that is how we can access a property of a reference versus of a pointer. So for a reference, you can just use the dot as per normal, just like a variable. But for a pointer, you can't use a dot. You have to use an arrow. And it's the same as well for functions. For example, let's say our player class had another function. Let's go into our header file and let's declare another function. We have get player weapon, set player weapon. Let's create some kind of active function, like for example, we could call this move. This is a function that could enable the player to move. Inside of the C++ file, let's implement the move function. It's void, it comes from the player class, and it's called move, and it doesn't take in any arguments. Inside of move, we can perform a simple task like, for example, just printing out the player is moving. And let's add in a line break at the end with end L. Alright, here we go. Now we have to make sure that we include our IO stream at the top here if we want to be able to print out messages. So just copy the IO stream, include from your C++ Introduction to C++ file, and paste it to the top here of your player C++ file, which will allow you to then use the IO stream, which allows you to print out messages. Okay, so now we have a move function for the player. And if we went into our main function and we just called player2.move, we'd be able to see that function in action. We would see that function will print the player is moving. But what if we wanted to use a reference or a pointer? Well, let's start with a reference. For the reference, you can just call player2reference.move as well, just like you would for a variable. And you see the player is moving is logged. But for a pointer, you have to use that arrow. You have to go to player2pointer, and then you have to use that arrow, which is that pair of symbols, and you can call move. And then you'll be able to use that move function from the pointer. So a slight difference in how you use a reference versus a pointer for objects and their properties and their functions. We're going to see a lot more of classes, objects, pointers, references, and more. Everything that we talked about when we build out our upcoming project, our game in Unreal with C++. So this has been our introduction to C++. I hope to see you in our Unreal game development with C++.